also a coffee roaster, so if you like coffee, so do I, and let's talk. So the sort of kind of core of this talk is about web browsers. Everybody has one. I don't think we can really deny much of that. It's one of the most dynamic applications that are built in the operating systems. And what's kind of fascinating about browsers is that the most technical people in the world who are, writing crazy PhDs and coming up with blockchain technology, it's a joke, to my mom are using web browsers in order to interact with the internet. They're hard to escape. And they're increasingly becoming more powerful with new functionality. So it takes many years for some of these things to ultimately make it into Google or Firefox or any other browser that you're using. But typically, ideas get proposed inside of a spec, and then it gets ultimately ratified into the browser itself. But you're having points now where there's things like WebAssembly, where you can literally execute code, and OpenGL, where you can have all these native 3D rendering and other details. And then just recently, there was WebRTC, I think it was. It kind of just got really solidified into the browsers. And that opens up the opportunity to literally do peer-to-peer sharing within your browser. That you don't necessarily need an application, that you can create peer-to-peer applications with just browsers. So it's pretty crazy, all of the things that we can do. And it almost reminds me of the days of Adobe and the PDF exploitation, is that there was so much incorporated into the PDF spec that it just opened up vectors all over the place for attacking. And browsers have significantly gotten hardened, but I still see them as a really big issue. And so lastly, if you think about the fact that we have to use these in some form to interact with the internet, then it makes sense that, and I think most people can agree, that they act as a vehicle, not always the delivery mechanism, that they're the one being exploited, but at the very least, they're helping facilitate most attacks that happen, be it a phishing attack or rendering something that ultimately gets exploited, or helping set up a heap spray, and to ultimately make the exploit possible. So there's a lot of weaknesses in browsers. Core technology stack and plugins, depending on the browser you're using, most of them are open source, so you can sort of look at that yourself. It doesn't really make sense as an individual to spend your time looking at browser stuff, and you almost have to rely on the company that's building that and hope that they're taking good security practices. But the browsers sort of force you into this paradigm that you have to use what's sort of built into it. So if I'm using Chrome by default, when I go and request something, it's going to put out a request to Google's DNS server, and they're going to get their information. So it requires me to sort of tune the browser in some way in order to get out of the native default built-in settings. And I'm not even going to bother reading this whole slide. I think you guys can read. The important part here is that there's a lot of weaknesses. There's a lot of ways that you can attack browsers. And for the sake of this talk, we're going to be focusing on a particular set of users that are often attacked, and the browser is a large facilitator in that. So attack success, the impact is relative. This is obvious to most people here. Personal users may have your bank account information stolen, may have your files encrypted, in this day and age, and you might not be able to get them back. They could be destroyed. For corporations, it's kind of the same holds true, but you also have company assets and intellectual property, things along those lines. And then there's this last category here, civil society. So civil society, I guess the way I would sort of define that is groups that are trying to do good in the world that may be oppressed in some form, or they may be getting, they may be, I guess that's the best way to describe it, really. A group of do-gooder people that might be attacked for their beliefs or persecuted for that reason. And so when somebody in civil society is attacked, the concerns of personal and corporate sort of largely go out the window. That's not as important. What is important is the fact that these people are often, and they're communicating about sensitive topics. They may be operating in hostile environments. And when they're compromised, that may reveal sensitive contacts. It may reveal sources. It may reveal people that they're interacting with. And that's a big problem because depending on where they are, that could lead to a number of other things. It could lead to detainment. And I put or worse here. And I'm not trying to sort of paint this bleak picture of what happens, but there is the stark reality that I think most people often ignore in our space, that anyone who's speaking out against the government in a country that may be repressive is potentially going to be tortured once they get detained or killed. It just depends on the circumstances, how vocal they are against the government, who they're going up against. So as you can sort of tell, we funneled into this portion. The talk here is around operations for those activist journalists and NGOs. So I recognize a lot of people in the room may not actually be, falling into one of those categories. And in fact, they may have, by show of hands, who's worked with any of these categories? Okay, so a small amount of folks. So if you haven't worked with these sort of folks before, you may just think security, it's hard, what's the big deal? And I think what's important to note here is just the ramifications that happen. That if I'm working with somebody in Syria, or better yet, if we pick a real example, FireEye put out some reporting probably 2 years ago. Civil war in Syria is going on. The Assad regime is essentially going and fighting the guerrillas. And in that case, the government is attempting to attack anybody who is helping support the guerrillas. And what they're doing is they're setting up honey traps through Skype. They're trying to get these troops to fall victim. This female is going to meet you at this place. These guys are lonely because they've been fighting for months. They've been away from their families. And it's not a matter of compromising their information. It's literally to get their lat long so that they can airdrop a bomb on them. And I think what's important to note here is that is the sort of the real world kinetic consequence of not having security in those regions. Another example might be the Chinese government going after Tibetans and trying to essentially lock up anybody who are within country, or just persecute them in any way. So this is a pretty big deal. I'm typically pretty lighthearted when I give this talk. I always have a hard time making jokes because it's a talk that's something that's important to me, and it's something that I've helped support for a number of years. And so if you haven't worked with activist journalists, NGOs, et cetera, and you want to, I can at least broker some communications to people that might be able to help facilitate that. And at the very least, you'll walk away with a better understanding of what it's like for those people and why, if you're a tool builder especially, how you might want to change your process to better cater to this audience. So in civil society, details to consider, I kind of put this in already, but compromises have real-world impacts. Could be meaning getting your location coordinates, gathering contacts, planting evidence in some cases. So, if the Iranian government wants to detain you, they might just have the police send porn into your account, knowing that evidence will be there. They'll then basically grab you. They'll look into the account that you have. They'll find this porn. They'll say, this is, crazy. They'll detain you on that. And then what they'll do is they'll essentially set up these false charges. And it provides an opportunity for them to go in and enumerate the rest of your contacts. So fun fact, I used to work at Facebook. One of the things that's pretty interesting is you can actually disable the downloading of your data if you are going to be traveling to a hostile region, simply for the fact that when people were traveling and they were being detained, Facebook is a massive aggregate of all this personal information, the people you associate with, all your contacts, phone numbers, et cetera. And they were finding that the government in certain countries would detain these people, force them to unlock their laptop, and then download all of their Facebook information wholesale and be on their way and enumerate that person's contacts. So that feature was built essentially to combat that, to stop governments from being able to force subjects against their will to download their data. So other details to consider here. When we talk about attack surface for a corporation, that could be 30,000 assets. It could be anything that you have that represents your digital presence. In the world of civil society, where it's often decentralized, and you may have people on the ground in spotty locations where the internet is not that great, or the communication is not great. you're not dealing with an organization. You may be just dealing with an individual. And so it's not always possible to say, like, well, chuck a firewall in front of it, or let's throw the WAF there so nobody can attack them, or let's put some sort of like sandboxing technology on their mobile phone. There's no body that's actually going to administer this. It's up to them to kind of self-police and use the community at large to figure out what they should be doing, what they shouldn't be doing. And what's important here as well is that we often consider attacks to be, we'll look at the sophistication of attacks and say, man, this attack is so easy to see, like, I can't believe they fell for it. But if you're attacking an individual, you might know who that individual is. You might know everything that they care about. You might be tracking them physically as well. I saw that they're leaving. I can then send them a text message that says, like, hey, we know that you're away from, they can do a lot of research, and so they can be a bit more detailed about the attacks themselves. So even despite having some less than sophisticated implants, being physically there in some cases, tracking these people, or having the extension of the government, being able to sort of use anything to their advantage, the ISP logs, phone logs, etc., puts these guys and gals at a disadvantage. And then overall, something to consider here is the general lack of funding, technology resources, subject matter expertise, etc. So their core focus is their mission. Their mission is not often anything to do with technology. It's about freedom of speech or protecting a certain class of citizens, whatever. And so they're not thinking about, did I apply the latest patches? Is the person that's emailing me trying to give me aid real or not? They want to get this information in. And so education becomes a critical resource in these communities, and a lot of them will actually go and educate each other, which the attackers will play off of as well. So the initial problem case, what does this talk about? How many people are familiar with the Citizen Lab? Okay, so they have really good reporting based out of Toronto, Monk School, and they focus a lot on nation-state tracking, cyber espionage, and like kind of basically protecting civil society. And a lot of their research is very interesting. So I've worked with those guys for a number of years, and the lab. And so several years ago, we were noticing, Tibetan groups that were being phished from, what we suspected is Chinese nation-state government. Email accounts were being compromised, and how they were doing, they were exploiting this community was they'd compromise one person's account, steal their email spool, download the attachments, implant them, and then they would go to another Tibetan group that was not part of the one that was on the original list. They would then send the weaponized information and the email wholesale from the compromised account. And so you can imagine, like, sort of all checks go out the window at this point. Like, we know it's a legitimate email subject. We know it's a legitimate email body. We know that the attachment's legitimate because our peers in another group just got that and it was socialized. And so, like, we have no reason to believe that this is a bad thing. But in the event that it's clicked, opens up a root shell back to their system and their host. And so we wanted to raise awareness here. And so requirements for success was, I wanted it to be, we wanted to basically find a way to let people know that, to have them stop getting exploited or have them be aware that they were potentially being exploited. So we wanted cross-platform, little change to the user behavior. As a product person and somebody who builds tools, especially in security, I think this is one takeaway that you could have regardless of where you work. I'm a huge fan of what I call like natural products. In other words, like, security should not force me to change my process. It should be baked into what it is that I'm already going to do. And so we can say, like, well, the user's dumb for clicking this. And I argue that it's a poor product implementation, that the user can click it, and that it's bad. So one of the requirements for a lot of the tools I build is almost little to no change to workflow. The person should be expected to continue to do what they're going to do, and we should safeguard them. So scaling with little money or technology, allow for collaboration, blocking specific resources that we deemed malicious, sending back data to a central location. I know this kind of runs counter to the privacy advocates, but when you're working with some of these groups and they are so decentralized, it really helps to understand who is getting targeted, because oftentimes what happens is we block the attack, good for us. That's usually enough for most people. But oftentimes somebody in that group would see that and they're like, oh, I want to know more. Who else is being targeted? Like, how can I help my community out and spread the word? And so that was a core piece of this. And then, of course, being open source. You know, we want people to be able to evaluate the code. And so what's funny here is several, iterations later, this is sort of a joke. But this started in 2013. And we did an initial proof of concept. We were in Bali at the Internet Governance Forum, which is a pretty sweet location. And we were talking about privacy and protecting Tibetan groups. And then we deployed like a proof of concept with some users in 2014. We redesigned the code in 2015. And it's just sort of evolved. This is years of evolution. And like I said, it's not groundbreaking, but what's important to note here is that adoption is very difficult. Like getting feedback is difficult. Knowing whether something works is difficult. So it's taken a long time to get to where we are now. But the output of all this work was something I've sort of relabeled as it's changed to blockade. And so this is the meat of the talk itself. What is it that we're doing here? And it's essentially a suite for browser defense. And so it's a browser extension that anybody can install with one click. You get the benefits of an extension that it's automatically updated, built into Chrome, but it supports the concept of these federated nodes, which I'll go into. And then most importantly, it's capable of blocking threats directly in the browser. And I'll kind of highlight how it actually works, and then at the end we'll do a demo. So the browser extension is pretty simple. As you can imagine, you install it, and it just works. That's nice, so I don't have to change my browsing habits. I just have to have it running. And then there's a cloud node, and so these can be, I say cloud, but it could be ran locally. And it's basically something that could be deployed on very minimal hardware. It could be a Raspberry Pi. It could be a set of serverless infrastructure, so you don't have to even deal with the footprint. It could be stood up within minutes on Docker, or simply just checking out the code. And beyond facilitating passing information to these browsers, we offer up an administrator API and a set of analyst APIs that allow research groups to sort of work with these cloud nodes. And then lastly, because analysts are lazy and even I'm lazy, we created sort of a tool bench where anyone who is working to support one of these nodes can essentially easily interact and publish content to the cloud nodes. And because analysts and security people are all about their privacy and or my special indicators of compromise, we actually remove the need to know the real value. We essentially hash it prior to even it hitting our servers. So I'll go into how that works a little bit later, but one of the stipulations was when we were working with research groups, they would say, well, these indicators of compromise are very sensitive. I can't give them to you. My customer told me no. And so despite it having a real-world benefit to these groups, we can't share it. And so by hashing that content, I don't really care what your indicator is. I just want to know that I can block it for these people. And then lastly, a couple built-in screening, whitelisting checks, so people don't mistakenly put in Google. So this is sort of like a information architecture, if you will. I'll kind of walk through this. In the first stage here, we essentially have cloud nodes that are installed locally, and we sort of give the users access to these public instances. And then anyone who has administrative access is able to essentially publish malicious and suspicious indicators inside of these nodes using the analyst toolbench or just sort of the REST API. And you'll notice here that we have intelligence, which in this case is domains and IPs, and then a number of different analysts. And so like I said before, you can share out the API with anybody that you want if it's a trusted party. So what's nice about this is if you have a bunch of analysts that are decentralized themselves, they can all contribute to this project as well, or they can contribute to one individual cloud node. Like I said before, indicators are hashed by the users, or they will be hashed prior to actually being posted to the cloud nodes. And so it avoids issues where somebody doesn't want to share a sensitive indicator, and there's no need for the cloud node or the extension to truly understand what the raw indicator is. So this is important because you imagine if somebody gets detained, all of a sudden like the government is looking at the local database that we push down, they're not going to necessarily know what the indicators of compromise are either because they're going to be hashed. So kind of a security through obscurity technique there. But once that's all set up, we have the browser extension installed. Extensions by default come configured with the blockade public cloud node. You can delete it if you want to. Data sync, a database sync is performed automatically. For the public node, it's every 15 minutes. And then what I think is important to note here from an operational standpoint is that deployments can be controlled through GPOs and master preferences. So while this is really geared towards civil society, I have friends in the espionage research community that are attempting to deploy this inside their enterprise just because they think it is a decent level of defense. And so essentially what happens is the indicators from the cloud node are essentially pushed down into the browser itself, and if small enough, it will be retained inside of local storage, which has a 5 meg limit, and if not, it'll essentially get bootstrapped into memory. Anytime that somebody restarts the browser, it essentially bootstraps itself. It understands whether or not the database is local. If it's not, it goes and gets it, stores it into memory. This is the important part here for any technical people. Extensions leverage built-in APIs that allow you to monitor traffic within the browser. So show of hands, how many people realize that you could monitor network traffic via a Chrome extension? All right, pretty good amount of people. So the web request on before request allows you to intercept any network request prior to them actually leaving the browser itself. This includes DNS prefetch and then the asynchronous JavaScript requests that are built into the page itself. And I don't know if the WebSocket part is done, but WebSockets was going to be supported in this as well. So in the event that we've identified and we've blocked something, we go and somebody's going to basically browse to something that we think is malicious. We do a lookup before it leaves. If we deem it to be malicious, we snub the request, then grab all the information associated with that request, store it locally in a little cache for a moment, and then essentially sync. Then we essentially sync that back to the cloud node itself. And so in the event that you've been blocked, you'll see something that looks very much like the GSB, that, hey, this is a suspicious site. And you could take me away, which will punch you back out, and then alternatively, slightly obscure there, but there is a way to sort of pass through and temporarily whitelist the resource so you can actually get to what you want. In the event that something is blocked, you'll see the little, it supports the desktop notifications, so you'll get that, and that's very helpful for cases where this is a real-world attack where the Russians had actually compromised this embassy website or this government website, and they were actually loading their profiling scripts in through Ajax. And so in the event that you're not presented with this suspicious site reported, we'll actually show you the fact that, hey, a GET request was made to www.mentalhealthcheck.net. We killed that for you. So it becomes an incredibly valuable tool just as you're browsing the internet as well. And so like I said, if we block something, we have all this information that's recorded and sent back to the user. There's an optional email address that can be included, so that allows us to get in contact with the user. And it allows the analyst to largely investigate this a bit further. And so lastly, like just as you're going through the browser as an analyst, there's some right-click context menus that allow you to, like I can configure my username and API for the cloud node that I'm part of, so that I can literally right-click on an indicator as I'm browsing, or maybe I go to a website, and I can submit that to a cloud node directly from the browser, which is then distributed back down to all the nodes in near real time. This is the information that we actually collect from the extension itself. So it's a bit of metadata. You'll see there that the indicator match is now in the clear, and that's simply because we match the two hashes together. And because we have the introspection of knowing the network content, we're able to figure out and deduce what the real indicator was. You'll also see a number of pieces of metadata there. That's kind of information associated with Chrome that sort of gives you an understanding of the request that was being made and a little details that the analyst can use to help further triage. So everything's written Python, Flask, easy to deploy. Alternative deployment strategy here is to simply go completely serverless. Like, how many people are familiar with serverless and that concept? Okay. So essentially not having a computer, like using these, drinking the Kool-Aid of Amazon in this case, to basically run in an ad hoc manner. This is very cool if you're interested in serverless. This is just interesting to look at my code simply for this and how awesome that is. And if you have not actually taken time to look at Amazon, it's definitely worthwhile. So let's tempt fate and try to do a demo. Alrighty. I did this morning. So what I'm going to do is I'm actually going to make an attempt to deploy the serverless setup that you just saw. And so what it's going to do here is it's creating all of the usernames, policies, groups, roles, etc. inside of Amazon. Hopefully it's not going to shit. Setting up the S3 buckets, the DynamoDB tables, the Lambda functions. Then it's setting up an API gateway that essentially facilitates and bonds all that information together. It's now creating all of the resources for the API itself and doing all the proper permissions. And in one moment, it's going to prompt me for an administrator email and then address. So it's actually, why can't you see it? Okay, there you go. So I'm going to type in Brandon at blockade.io, my name. And so what's going to happen here is it's actually going to add that user using the API that we just created on the fly in this magical serverless land. And so what happens is we now have a blockade server, my admin user, an API key. And so I already have the analyst toolbench installed, and I get this nice little convenient copy-paste into my terminal. And what that did was it just linked that cloud node to my analyst toolbench. And so now what I'm going to do is, right now I can browse the isotf.org, but let's just for giggles, we're going to essentially use the blockade tool to essentially submit that into the new cloud node that we just did. So it gets, we just posted that in, so now it's now part of that setup. And what I'm going to do is I'm going to configure my browser to essentially use this cloud node inside of blockade. So I had a video just in case. Get some. Okay, so I'm going to save this node. That's added. It's part of the configuration now. And so just, that's going to sync, but really quick, one of the things that I can show you guys really quick while that's happening is the analyst toolbench allows you to essentially perform actions with IOCs. So I can do a single IOC, I can do a full file of IOCs. And like I said, it'll whitelist things, it'll go and make sure that you're not doing anything silly, and then it'll also pre-cache them as well. So that if you are running in a serverless environment like I have, you don't have to worry about any extra charges. Though everything that you're going to see here runs on the free tier, and it will continue to run on the free tier as long as you don't do anything crazy. And so let's see. At this point, I think it should have synced. It did. So you saw I just refreshed it. And essentially what happened here is we blocked that website because the indicators got pushed down. This, I could bypass this if I wanted. We include some raw information here. And if the demo gods really love me, we have that event information that was supposedly sent back. And so I can make a request for it, and not there yet. There it is. So this is raw and ugly, but you got your raw JSON response that you saw in the slides before, and then we format this just a little bit. And so we saw here that I tried to go to this particular website. It was a GET request. It was in the mainframe. You see all the other information associated with it. Successful demo. And so let me just wrap up here. You might be asking yourself, is this Google Safe Browsing? Yes, it's very similar with a few distinct benefits. It's not a corporation. It's open source. It's freely available. You can do whatever you want with it. That's a very important thing. It's not backed by a product company. It's also a targeted database as well. So, I've tested this with hundreds of thousands of indicators, and it scales fine. And so you can feed information back to the operator, so if you deploy this internally, it can be a helpful intelligence tool. And it most importantly requires little change to the actual behavior. State of the project, I consider it a beta state. It's currently being used with the Citizen Lab and Security Without Borders. Security Without Borders is Claudio, who wrote Cuckoo, works at Amnesty International. If you want to contribute code, there's code. If you want to contribute research, because you do espionage research, or you want to contribute to civil society in some form, feel free to talk with me. I can get you plugged in the right people and helping contribute to these nodes. If you know any activist journalists, NGOs, etc., and you think that this is a cool project, feel free to send that information over to them. I'm more than happy to talk. And that's it. There's a Chrome extension. Website's open source. Analyst Toolbench is open source. Cloud Node's open source. The AWS server deployment scripts are open source. And there's a Firefox extension that needs some love. And so just because you guys all saw, my stuff, I'll just, I don't have any times for question here, but I'm going to tear down everything in the Amazon Web Services now, so we're essentially destroying everything that we just set up in that few moments. 2 minutes over. Thank you guys, very much appreciated. And I will try to answer one question. Shoot.
So for being able to submit via new bad things via the API into that, is that just for an administrator or operator to do that, or can the clients do that? Or?
Technically the clients could do it, but it's really meant for the administrator or operator. Okay. So the use case of how this might actually be applied is the Citizen Lab may be working with a particular Tibetan group, and they may be the one that's actually administering it, and then they would essentially pre-configure these extensions. They could submit them out of band, or they could say, go to the Google Chrome store, download this, MD checks it, do the checksums, etc., and then configure your blockade instance to go use that cloud server.
Okay, and then to extend on that, so there's not currently a way where if you deployed this in mass, if the end users could have a different level of API where you'd have to get at least 8, or your backend would have to be, I need at least 10 submissions that match this
Sure.
in order to be able to.
Basically role-based access control or something like that, so that. Yeah. I could propose something. A user could submit something as a proposal, this is bad, right?
Yeah.
No, there's not, but I'm more than happy to add it. That's actually been requested because there's different tiers of analysts as well. There's very basic analysts, and then there's very sophisticated ones. And so the sophisticated ones come to me, and they're like, I want to have this scale, but I do not want to give it to some dude who's just going to try to block something that's completely legitimate. So I'm happy to sort of work with anybody and I just want somebody to test. That's the thing that motivates you, because when you're sitting there doing these projects, it always helps to have someone who's pushing you along. If you guys want to contact me, Brandon at 9B+ or info@blockade.io. I got to run, but I very much appreciate you guys letting me talk and and hang around. If you have any more questions, shoot them on email. Thank you.
Thank you, Brandon. So we're going to be on break until 10:50. It's about 15 minutes, and then we'll be next presentation is regarding Bro. Thank you. 10:50.